Good day, learners. My surname is Botha, and I will be responsible for today's lesson. Today's lesson is on reflection and refraction of light. So first we will start with definitions, and starting off with reflection of light. Now, what is reflection of light? Reflection of light is when a ray of light approaches and strikes a smooth, polished surface like a mirror, and the light then bounces back, or it bounces off this mirror. That process is called reflection. Different terminologies that you need to know when it comes to reflection of light. Firstly is that when you look at the picture here, there's a red beam of light that moves in and strike the surface. We call that the incident ray. So that is the incident ray. And then when it strikes the surface and it bounces off and moves away, we call it the reflected ray. So this is the incident ray, that is the reflected ray, and the reflection actually takes place at this point here on the surface of this, or this polished mirror-like surface. Then the angle of incidence. The angle of incidence, according to the definition, it says the angle between the incident ray on a surface and the normal. It's this pink angle here, and it's labeled I. That is called the angle of incidence. Now, what is the normal? The normal is just an imaginary line. We can draw it in the form of a broken line, and it sits perpendicular on the surface of the mirror, and it starts there at point of incidence, or where the incident ray strikes the surface. From there, you draw a perpendicular line. And now the angle of incidence is this angle that forms in between the normal and the incident ray. The angle of reflection is this blue angle labeled R, and that is the angle between the reflected ray and the normal. And then just lastly, there is an important law that you need to remember, and which we will also use in some of the calculations, and that is the law of reflection of light, which just very simply says that the angle of reflection is always equal to the angle of incidence when it comes to reflection of light. You can see here, mathematically, we can say that I is equal to R, which actually just means that the angle of incidence is always equal to the angle of reflection. When we increase the angle of incidence, you can see I'm putting a green ray of light here, and it's further away from the normal, meaning that the angle of incidence now is bigger. That will then be the reflected ray, but the angle of incidence, although it's a bigger angle now, will always be the same size as the angle of reflection. Right, moving to examples. The first example that we do is, it says here, what will the angle of reflection be if a ray of light strikes a mirror at an angle of incidence of 45 degrees? We can see on the picture that the 45 degrees here is the angle between the normal and the incident ray. It's indicated there as 45 degrees. It's called the incident angle. And now this question mark asks us, what will the angle of reflection be? Now, if you use the law of reflection of light, we know that the angle of incidence and the angle of reflection is always the same, and therefore in the answer we can see that the angle of reflection will also be 45 degrees, because the angle of reflection is always equal to the angle of incidence, and that's according to the law of reflection. Second example, slightly more difficult. Now, when looking at the picture, it says a ray of light strikes a mirror at an angle of 65 degrees to the surface of the mirror. Important to know, this is not the angle of incidence. It's this angle is between the surface of the mirror and the angle of incidence. And now we must determine the angle of reflection, which is that question mark. We cannot say that the angle of reflection now is also equal to 65 degrees. We first have to go and calculate the angle of incidence. Now to do that, you can see that it says here the angle between the normal and the surface is 90 degrees always, because the normal is drawn perpendicular to the surface. So to get the angle of incidence, that little angle sitting there between the normal and the incident ray, we deduct 90 degrees, we deduct 65 degrees from 90 degrees. And it's indicated here. 90 degrees minus 65 degrees will give you that 25 degrees, which is the angle of incidence. And then that angle of incidence, as determined 25 degrees here, will give you that angle of reflection, and that is according to the law of reflection. So doing your calculation, you can see the angle of reflection is 25 degrees. Right, learners, now we move to refraction of light. Firstly, what is refraction of light? Refraction of light is the change in direction of a light ray when passing from one medium to another. When you look at the picture here, this is our incident ray in this case, same as in reflection. But instead of this light beam reflected off here, remember this surface is not a mirror or a smooth surface. This is just a boundary between two optical dense mediums. The yellow area is air and the blue area is glass. So this incident ray moves from air, then it moves into the glass. It can actually move through the glass, but it doesn't move through the glass in a straight line. It changes direction here at this point of incidence. And there's a few factors that determines this change of direction. The major factor is the difference in optical densities. The yellow part is low optical dense. This is a high optical dense medium. So when the light ray strikes here, it actually slows down because it's got a higher optical density, this glass block. And then it's bent, it changed direction. And in which direction? It changed direction towards the normal. We can see that alright, in terms of the definitions, this angle labeled I is the angle of incidence. And now this angle here is not the angle of reflection. We call this now the angle of refraction. And we can see that the angle of refraction in this case is smaller than the angle of incidence. It is because the light ray was bent towards the normal. And why did it happen? It's because the light ray went from a medium of low optical density to a medium of higher optical density. When you look at this picture here, if the light ray moves from a dense medium, let us say that now this is glass, the blue area is glass, it's a very dense, optical dense area. It strikes the boundary, and now instead of just moving through, now it is bent, it changes direction away from the normal. So it is refracted away from the normal. We can see that the angle of refraction in this case is bigger than the angle of incidence. So remember these two examples where light is either moving from a low optical dense medium to a higher optical dense medium. The light is slowed down and then it's bent or refracted towards the normal. And in this case, when it's moving from a high optical dense to a lower optical dense medium, it is refracted away from the normal. You must always also remember that no refraction will take place when a ray of light moves from one optical dense medium to another at an incidence angle of 90 degrees, meaning that when this light strikes the new medium at a right angle, it can slow down if this medium has got a higher optical density, but there will not be a change in direction. So the light will just move, slow down a little bit, but it will continue to move in a straight line. This is just another example. If you take this white area as air, which is a low optical density, blue is a glass block, higher optical density, and again we've got air, which is low optical density. So when your incident ray strikes the boundary here, it moves from low to high optical density, it slows down, and then it's refracted or bent towards the normal. Then the light ray continues to move. It strikes the second boundary, but now it moves from high optical density to lower optical density. So it accelerates here and it's bent or refracted away from the normal. Now this we actually call the emergent ray. It's a special name that we give to this refracted ray when it exits the second boundary. It's called the emergent ray. And an interesting thing to see maybe is that your first incident ray and this emergent ray is parallel to one another, and then this angle of incidence initially is equal in size to this angle or this final angle of refraction at the end. Lastly, learners, let us look at how we can split white light into its different colors by using refraction. It says here, refraction of white light through a triangular prism will be used to split white light into its different colors. Firstly, what is white light? White light is a combination or a mixture of 7 colors of light, and this mixture is called a spectrum of colors. How can we break or split up this light into different colors? It can be done as follows. White light can be split up into different colors using a transparent glass block, triangular in shape. You can see here at the bottom, this glass block is triangular in shape, and then a triangular, and we call it a triangular prism. It's specially shaped in such a manner that light is refracted or it bends when passing through it in a special way. Some colors of light bend more than others as they pass through the prism, and in doing so, colors are split apart. You can see white light enters here, and there at this boundary we get refraction. Red light is refracted the least, and it's because red light has got a long wavelength and it slows down less than, for instance, the green and the blue and the indigo, which has got smaller wavelengths, and they get refracted more. When these colors of light hits the second surface, they get refracted even more, and then we can see here this nice colorful band of colors, which we call the spectrum of white light. Now, for you learners, it's very important to know the sequence of the colors of light, starting with red, then orange, then yellow, then green, then blue, then indigo, and then violet. And you must know the sequence or the order, moving from red at the top, the one with the longest wavelength, which is refracted the least, up to violet, the one with the shortest wavelength, which is refracted the most. Right, learners, following this, you'll find the quiz. Good luck with your quiz.